Hello, I'm Michelle Kim, and this is my AP Calculus AB arc length project. Over the past few months, I realized that my dog was starting to gain weight. As a result, I decided that I would walk my dog a certain amount every day in the summer in order for her to lead a more active and healthy lifestyle. So, I researched and found that dogs should get a minimum of 60 minutes or 1 hour of walking daily, while an average human walks at approximately 3.1 miles per hour. However, I am a slightly slower walker, so I estimated that I walk at 3 miles per hour. So, the healthy amount of walking for dogs is 3 miles daily. To make sure that my dog enjoys the exercise, I will use the path that encloses her favorite park, Whit Memorial Field, Johnson Park in my town, Inglewood Cliffs. As you can see, I used Google Maps to draw the path. However, this path is definitely less than 3 miles. Therefore, I needed to find out how many laps that my dog and I need to walk to complete at least 3 miles. And I'm going to use calculus to do so. Using the measuring tool in Google Maps, I measured all of the straight segments, as you can see in the picture on the right. So, I was able to find that this path consisted of 9 straight segments and 2 curves. After finding the lengths of all 9 straight segments, I moved on to find the length of the 2 curves. For the first one, I flipped the curve and fit it on an XY coordinate plane. Then I found 9 reference points by using the measuring tool that was previously used. After, I plugged these points into the online program Desmos and then created a parabola of best fit. This tool was very convenient because Desmos immediately provided the regression formula that I would need for the next step of the process. For the first curve, the regression formula turned out to be fx equals negative 0.013628x squared plus 0.85461x plus 0.71451. Then, finally, to find the length of the curve, I had to use the arc length formula, which is stated on the left. I plugged this equation into the online calculator Wolfram Alpha, and it gave me its derivative, which I need for arc length. Then, using a TI-Nspire calculator, I solved the arc length formula to find the length of the first curve, which turned out to be 79.7499 feet. Next, I basically did the same thing that I did for the first curve. I flipped the curve once again to fit it on an XY coordinate plane, and instead of 9 points, I found 6 points using the measuring tool on Google Maps. Then, I plotted these points on Desmos, found the parabola of best fit, and obtained the formula of regression for this function, which turned out to be f of x equals 0.009918 x squared minus 0.3938x plus 0.33061. Then I plugged this equation into Wolfram Alpha and found the derivative. Finally, I plugged the arc length formula into my TI-Nspire and found the length of the second curve to be approximately 72.3112 feet. So, as this path consists of 9 straight segments and 2 curves, I added all of these components together, and I got 1,720.06 feet per lap. As my original problem is in miles, I needed to convert this length to miles. So I divided 1,720.06 by 5,280, as there are 5,280 feet in a mile, and I got 0.3258 miles per lap. Once again, the healthy amount of walking for dogs is 3 miles, and 1 lap around the path of Whit Memorial Field is 0.3258 miles. So, to find the number of laps needed, I divided 3 by 0.3258 and got 9.2081 laps. Therefore, in conclusion, in order to complete the minimum amount of walking required for a dog's healthy lifestyle, I will walk 10 laps of the path of Whit Memorial Field every day in the summer. Thank you.